The largest and most powerful wind turbines on Earth can have blades, which are about 350 feet each. Some of them stand about 850 feet above sea level. The electrical energy generated from a single rotation is enough to power an entire home for 2 full days. A single wind turbine of this size can provide electrical power for approximately 15,000 homes for 1 full year. The wind turbine technology is based on a simple concept. It is a device that converts the kinetic energy of wind to mechanical energy and finally into electrical energy. Some of the fundamental parts of a wind turbine are the blades, rotor, generator, nacelle, the hub, and the tower. For a wind turbine to be fully functional, it needs to follow some scientific principles of physics and aerodynamics. After a wind turbine has been mounted, wind flows over the blades and causes them to rotate. However, for the blades to rotate smoothly, some principles of aerodynamics must be followed. The blade of a wind turbine is crafted into a specific shape known as the airfoil shape. An airfoil is a streamlined shape with a curved upper surface and a flatter lower surface. The curved upper surface of an airfoil is referred to as the camber. This curvature is essential for creating a pressure difference between the upper and the lower surfaces of the blade. The science behind the airfoil technology is closely tied to Bernoulli's principle, which states that as the speed of fluid increases, its pressure decreases. The curved upper surface of the airfoil causes the air above it to travel faster than that of the flatter lower surface, resulting in a pressure difference between the two surfaces. This creates a lift force, which causes the blades to rotate effectively. Larger turbines with longer blades tend to capture more wind energy and operate more efficiently. As the blades spin, they turn a rotor connected to a generator, which is located in the nacelle. The rotor's rotational speed depends on factors such as wind speed and blade design. Inside the generator, the rotating motion of the rotor shaft interacts with magnetic fields, inducing an electric current in the coils of wire. This process follows the principle of electromagnetic induction, which was introduced by Michael Faraday in the 19th century. The current produced by the generator is transferred to a transformer inside the tower through a long cable. This is where the current undergoes voltage regulation and conditioning before being fed into the electrical grid, which is then distributed to various homes. Alternatively, in remote areas or off-grid installations, the electricity may be stored in batteries for later use. To harness the wind effectively, wind turbines must be able to align themselves with the direction of the wind. To help this situation, there is an anemometer on top of the nacelle, which measures wind speed, while there is also a wind vane which determines wind direction. The real-time data is used by the turbine's control system to adjust blade pitch and yaw angle, ensuring efficient operation under varying wind conditions. This is known as the yawing mechanism. The orientation of the blade also determines the efficiency of the wind turbine. Vertical axis wind turbines have blades that rotate around the vertical axis. Horizontal axis wind turbines have blades that rotate around a horizontal axis. Many wind turbine blades are made of fiberglass and have a lifespan of about 20 years. The blades must be strong and stiff, lightweight, and also resistant to fatigue. Now, there is always a limit to how much wind energy can be converted to electricity, no matter how massive and powerful the wind turbine may be. This is known as the Betz limit of power extraction. In 1919, a German physicist named Albert Betz showed that no wind turbine can capture more than 59.3% of the kinetic energy present in the wind, since some of the wind must remain to keep the blades spinning. Wind turbines have a maximum wind speed called the cutout speed, at which they shut down to prevent damage. The cutout speed for most modern wind turbines is around 25 to 30 meters per second. Wind energy is not a new concept. Humans have been utilizing wind power for centuries. Wind energy is infinitely renewable as long as the sun shines and the earth rotates, making it a sustainable alternative to fossil fuels.